Guys, it's question number 4 of AISL May 2025, paper 1, question of time zone 1. Question number 4, let's make a first overview. It takes 5 marks total. It means again it's about 5 minutes to solve, and we have a diagram and we have 2 questions, part A and part B, with 2 and 3 marks respectively. Okay, first of all, it's better to read the question first, show that swimming pool satisfies the safety regulation. Okay, so if we will look at the diagram, yes, by the way, sometimes it's save time to consider the diagram first. So usually the most information given in the diagram is enough. So all information usually represented in diagram. So it's a good hint to avoid reading the initial conditions, because it explains the same thing. It says that it is swimming pool, and this is a cross section of swimming pool. That's it. So a cross section of the water. Okay, and now let's turn to the question itself. So it says that show the swimming pool satisfies the safety regulation. Okay, the safety regulation states that the gradient of the slope floor of the swimming pool as shown in the cross section must be not greater than 1/2. Okay, so slope floor. So this is a keyword here, and you see that it is this inclination, yeah, and we should find the gradient of this sloped floor. How to find the slope? Remember, so it's a formula for the slope. It's a rise by run, or we can say that it is delta y over delta x, and sometimes, to be more precise in terms of the points, it's y1 minus y2 and x1 minus x2. And let's see which form is more appropriate here in this question. I think it's better to construct the triangle straightforward. So we can make a triangle straightforward, and now we should calculate the sides of this triangle. So this first, to underline, it's a right angle triangle, and we should find the sides of this triangle. Okay, and you see, playing with these numbers, we can say that the total length is 7.5, and from 7.5 we should subtract first 3 and 1.8 to find this side of the triangle. Okay, so this side of triangle is equal to 7.5 minus 3 minus 1.8. So using the calculator we can obtain that this value is equal to 2.7. Okay, and this is a rise. Yeah, this is actually our rise of the slope. This is actually run. Yeah, sorry. So this is a run for sure. It's a run, and now we should find the rise. And how to find the rise? So now to find the rise, we have to do the same thing. From these 2 meters, we will subtract 1.2. Okay, so it is 2 minus 1.8, 1.2. So it is 0.8. If we will construct triangle separately, let me show here. So we have this triangle, this 2.7, and here is 0.8. And now using the equation of slope, we can simply divide rise by run, 0.8 divided by 2.7. Okay, and now we will get the value of 8 over 27, or using the calculator you can say that it is 2.93 for 3 significant figures. Anyway, you will compare this value with the 1/3, right? So we will compare this value with 1/3, and we know that 1/3 is 0.333 and so on, yeah. And yeah, so this value is less than this safety requirement. So it is, that's how we solved the part A. Okay, so we've shown that swimming pool satisfies the safety regulation. So it takes it should take about 2 minutes, and let's go to the next part. The time to fill the pool with water inversely proportional to the water flow rate in liters per minute of a hose being used. A hose with the water flow rate 300 liters per minute will completely fill this pool from empty in 4.5 hours if the hose is run continuously. Determine the time it takes to completely fill the pool from empty using a hose run continuously with a water flow rate at 170 liters per minute. Okay, so first of all, it looks very, very wordy, but if we identify the key terms, we will be good. Okay, so let's go. The time taken to pull inversely proportional. So this is a keyword, inversely proportional. So time inversely proportional to the flow rate. Okay, so water is inversely proportional. We use this sign, inversely proportional to the time, right? To the time, like this. Okay, it means that we can say that W is equal to K. This is a coefficient, proportional coefficient. K multiplied by 1 over T. Okay, and now we will use these two pieces of data to find K. It's actually usually how it works when you see the word proportional, direct proportional or inverse proportional. There are two options. All the time we do the same way. So we find K. So let's first underline the initial conditions. So this is liters. So W is equal to 300 if hours, number of hours, T is equal to 4.5. Now let's plug our values into our equation, and that's how we will get the value of K. So K will be equal to 300 divided by 1 over 4.5. So 300 multiplied by 4.5. In calculator, you can find that the value is 170. The value of K is equal to that much. Yeah. Okay, let's leave this value as it is, and now we will turn to the calculation. Now we should find the T. So it says determine the time it takes to completely fill the water pool. Okay, so we have W is equal to K, so this value 4.5 multiplied by 1 over T. Okay, and it says that the water flow rate is 170. So the T will be equal to W is equal to 170 is equal to 300 multiplied by 4.5, 1 over T. Now we should find the value of T. Okay, so we should find the value of T. You can use your calculator or somehow else. Let's multiply everything by T. 170 T is equal to 300 times 4.5, and T is equal to divide by 170, so it is 7.94. Okay, so for three significant figures our value is 794. Okay, so done. So we have 3 marks. The first mark is for method. So if you wrote this row, it's you will get one mark. If you if you found the coefficient of K, it is another mark, A1 for answer, and the last mark for finding T, so it is another A1. Okay, so it was question number 4 about inverse proportion and about the gradient formula. Let's move on. Let's go to the next question. See you in the next video.